Hey, everybody. Welcome to our last scheduled live stream for this particular series. We started this last month or earlier this week. It's been a long day, but we started this to support the students who are currently in the CompTIA Tech Plus certification course with Latinas in Tech out here in Houston. And they should be finishing off very soon and taking those certification exams. So keep on studying out there. I can't wait to hear how y'all do. Also, we got the We Teach folks out here in the Region 4 Hub who are watching these for fun. Now, quick disclaimer before we get going. Sad news here in the office. For those of you who don't know, I rent an office. I actually rent through Regis, and I'm supposed to have unlimited coffee. And once again, the coffee machine is broken, and I'm reduced to drinking this clear fluid. I think y'all call it water, but I'm going to be drinking water. I've been here since 9 a.m. It's currently 6 p.m. out here Central Time, so I'm going to try my best. But if you're hanging with me, we'll work through this together. So let's hop into today's live stream, which is going to be a bit of a long live stream. We're going to be talking about WAN fundamentals, virtualization, and cloud computing. These are things that are on the certification exam, on the Tech Plus exam, that you need to be aware of. So we're going to cover this. Originally, it used to be part of the whole networking fundamentals core or the unit, but we broke it out into different units. So we've covered previously last week the networking fundamentals, and we've covered the wireless fundamentals. And so we're wrapping up our conversation on networking tonight with, like I said, WAN, virtualization, and cloud computing. So let's hop into the presentation, and I'll be keeping an eye on the chat. So if you're joining us for chat, just keep in mind there is a little bit of a delay between what I'm saying and what you're hearing. Also, we have two different Kahoots for you. We're going to do our first Kahoot after our conversation about WAN technology, and then we'll do our last Kahoot at the end of the live stream. So here we go. So taking a look at WAN fundamentals and all this other stuff. So our objectives for tonight are describe wide area networks, explain IP addressing, IPv4 and IPv6. Don't worry if that doesn't sound familiar. You'll become well acquainted with it in just a little bit. Identify types of IP addresses, or excuse me, I should say classes. Compare and contrast common internet service types, or as cool kids call it, ISPs. List and describe basic networking protocols, perform basic configurations on web browsers, explain virtualization, and contrast type 1 and type 2 hypervisors. We'll learn what hypervisors are. If you're like, what's a hypervisor? Don't worry. And give a brief description of cloud computing and common services. And real quick, let me pop back here. We're going to look at internet service types, not internet, internet service providers is ISP. Internet service types is how you get to the internet. Oh, the lack of coffee is already coming in and kicking my butt. Honestly, trust me, I'm a professional. So let's look at introduction to wide area networks. So in the networking fundamentals unit, we took a look at the different topologies based off of geographic location, right? We've looked at PANs, personal area networks. We looked at LANs, we looked at CANs, we looked at MANs, and I said we were going to take a look at WANs in more detail. Well, that time, my friends, has come. We are going to look at WANs in more detail. So a WAN stands for wide area network. Large distances separate the components. These are massive distances between your LANs and all that fun stuff. The internet is an example of a WAN, but there's other WANs out there besides just the internet. For example, major corporations have WANs and the military has WANs. So while the internet is a fantastic example and one we commonly use, it is not the only WAN out there. Otherwise, we wouldn't have the word WAN, we just say the internet, but you get the idea, okay? Then, of course, routing is the key that makes all of this happen. So I know y'all been waiting to hear about IP basics. You want to know more about IP. I know y'all do. And I kind of alluded this to in the last 2 live streams. So let's think a minute about a phone. Okay, now for those of you youngsters out there, these are called payphones. They would connect to a landline and you would pay money to make a phone call. I can't remember the last time I saw a payphone. I think it was on the way out to Las Vegas, some back area in Arizona or something. Anyways, think for a moment about the phone. You call or text somebody, you need that person's phone number, right? The phone number, you can call somebody in the same room, right? If you want to call somebody with a phone number, let's say I'm sitting at home and my kids have got their headphones on, they're playing games and they can't hear me yelling and I don't want to get up out of the couch because it's been a long day. I can call them. They're right down the hallway. I can make a phone call. Or, for example, my oldest son went to a geeky convention, I want to say out in Georgia somewhere, and I can make a phone call to him all the way out there. I can also call across the seas. I can make phone calls. We do this based off a phone number, right? We use a phone number to make the phone calls. So imagine instead of using a phone number, we use something for computer to computer or computer to other devices known as an internet protocol or IP address. So think for right now of your device using a phone number, we'll call it an IP address, in order to make calls from device to device, whether it's local or around the world somewhere else. So little fun trivia for you. If you're a fan of Fallout, there's a phone number you can actually call, and I called it recently. They have changed the message. Originally, the message was, I think it was during season 1, where if you called the phone number, you just heard people screaming on the other end of the phone call. If you call this number now, I won't spoil it for you, but you'll get a recorded message, and do it after the live stream. Now, obviously, don't do it now because we're learning, and I don't want to be too much of a distraction. But you can make that phone call and hear what they have set up for you. All right, so what is an IP really? An internet protocol, or IP, was created a very long time ago, back in the elders of the internet. If you're fans of IT crowds, you got that reference. It works on the network layer, OSI layer 3. We talked about the OSI model and the layers in the networking fundamentals live stream. It can be found both on huge and small networks working effectively. In fact, back when I got into computers, we had to learn about other ways to give names to devices on a local network. So you didn't use or didn't have to use IP addresses. Well, IP is so efficient and so effective at communication, I don't even think they teach the other ways to communicate now on local networks. I think it's all IP addresses, as well as it should be. There are 2 versions of IP addresses. There is the older, venerable, ubiquitous IPv4, Internet version 4, and the newer, hip, more robust version that's been the new version for a couple of years now, a long time actually, called IPv6, and we're going to learn about both of these. So IPv4 address, we have 4 groups of numbers called octets. Now, if you were in my face-to-face class, or if you're taking our course through StackFord, or let's say you happen to look at my book, you're going to discover at the beginning of the course, we look at binary and we look at conversions and we look at how to convert base 10 to binary and back again. And when I'm teaching this, I tell the students, look, we just group them like this. We're going to leave it alone. Just understand that we group them into these 4 groups called octets, and we'll learn about why we do that later. Well, it's later. Okay. So we have these 4 groups of numbers called octets. It ranges from 0 to 255. So for example, you might see 127.0.0.1. You might see 10.0.5.20. Notice I'm saying dot and not period because that's just what we say. Now, what you don't see, what's on the back end of all of this, what you're not seeing, is IP addresses are made of 1s and 0s. It's binary. It's 0s and 1s, 0s and 1s, 0s and 1s. IPv4 addresses is a combination of 32 ones and zeros. An octet is made of 8 of those ones and zeros. We convert the binary format of ones and zeros into something we humans can use. So the IP address that you see, like the 127.0.0.1, is not what actually the computer uses. That's how us humans interact with it, because if we did it the other way, well, it would just be a huge string of numbers. So the things that we see for IP addresses is for us humans to more easily interact with these things, okay? Now, talking about IPv4, we have something called a classful network architecture. And the 3 most commonly used hosts on a network are A, B, and C. And there's a special class called D and E that we're really not too concerned about in the Tech Plus course or at this level. But the A, B, and C we're definitely interested in. Now, taking a look at this slide, the class, whether it's A, B, or C, is based off of that first octet. Okay, so no, hold on a second. You might be going, you just lost me. Out here in Houston, we have 832 phone number, 281 phone number. These are our area codes. You might have a phone number with an area. Well, I know you have a phone number with an area code. For example, I remember living in South Florida and our area code was 941. And I still remember when we started having to dial area codes because there were just so many phone numbers. And oh my God, I realized as I was queuing that up to say how old I really am. But we have area codes, right? 832, 701, 941, 8675309. We have all these different area codes that tells us where we're calling, right? What city are we calling? If it's a huge city, we also might get region in that city. But that first 3 numbers in a phone number is the area code that tells us, hey, we're dialing over here. We're defining the location. Well, in IP addresses, that first group of numbers, that first octet, tell you what class you are using. Okay, so don't make this more complicated than it needs to be. That first octet tells you what kind of class it is. Now we're going to fill in this table as we go through this, but you can see if the IP range, if the area code is from 0 to 126, it is a class A. If it's from 128 to 191, it's a class B. If it's from 192 to 223, it's a class C, so forth and so on. Now, the observant person out there might go, you missed some. No, you missed a number. You got 126, and then you jump to 128. What happened to 127? Well, I'll tell you later, but not right now. Okay, so then we have something called a network or a host. The class of the IP address determines which part is the network and which is the host or node portion. Now, don't get confused. We're going to make this really easy here, okay? The network part is what belongs to your ISP, your internet service provider. That belongs to them. That is the number that they are given. That identifies whether you're using T-Mobile, TACUS, Comcast, whomever. That belongs to the company that you're paying money to use their internet access from. The other part is called the host. This is what the company then gives you to get online with. So the network portion belongs to the company you're paying money to, while the host portion belongs to you. Now, let's really quickly do a quick little side trip here. Let's say, for example, that you are pirating a movie. Okay, let's say you're pirating a movie and you're not using a VPN. You're not being smart. Okay, and what winds up happening is there are companies who are watching like the torrent sites and watching the torrents being shared, and your IP address is being sent along with what you're doing. Okay. Finding an IP address is not that hard. It's not like super secret hacker stuff and, acid burn or zero cool. Okay. They find your IP address. They go, okay, the area code, what company, that first part, or that network part, I should say, who does that belong to? What company owns that? Is it Comcast? Is it who owns that? Okay. They don't know who the person is, but they know the company that's given the IP address. And so then they're going to reach out to Comcast or whoever and say, hey, at 5 o'clock on this day, somebody who's one of your customers, here's their IP address, was illegally sharing these movies, this music, whatever. Your hosting company then goes, oh, we assigned this to John Smith at this point in time. He was the one who was doing that illegal activity. And then they send John Smith that letter that says you better stop or we're going to cancel your internet access. Okay. So the network portion determines the company, right, that has given you the address, while the host portion is given to you by the company itself. Now, you can see here, based off of the class address, so we got A, B, C, right? Based off of what class it is, determines how much of that IP address belongs to the company and how much they have to send out to their users. So a class A has a possible network of 128. So 128 things can have a class A address. There's not a lot, but look how many customers they can give it out to. Okay. Class A are typically very, very large organizations like the government or the military, which I guess is the same thing. A class B is kind of a mix between the two, where they can have 16,384. Not important what the numbers are, but you basically get the idea that from A to C, there's more that belongs to the network and less that belongs to the host, which means up here at A, you don't have a lot of networks that can have these addresses, but they can have a whole bunch of people using them. While class B is kind of the mix. And then class C, you have a whole bunch of companies that can have a class C address, and they can't have too many customers per those IP addresses. Now, what wound up happening is when the internet was created, we didn't think that there'd be that many devices on the network. In fact, when the internet was first created, I'll talk about this later, you could fit the entire internet on a piece of paper. You could map out the entire internet on a piece of paper. Well, obviously, that's no longer the case. Things have absolutely blown up since then. Okay. So then we have something called a subnet mask. Now, we are not going to do subnetting in Tech Plus. You do not need to know about subnetting. All you need to know about subnetting is it's fun. The subnet, I did not mean to sound that evil and laugh. I apologize. Again, I blame the lack of coffee for that evil laugh there. But the subnet mask identifies the network versus the host portion of the address. So you might see, for example, a subnet mask of 255.255.255.0. This identifies that first 3 octets as being from the network, belonging to the company that you're getting access through. Okay. A router looks at the network portion to determine if the data is local or outside the network. And that is all you got to worry about when it comes to a subnet mask. Now, in A+, if for those of you going on to A+, you need to know a little bit more about the subnet mask, but you're still not subnetting. You don't have to worry about subnetting until about the Network Plus portion. And I'm trying to remember kind of how in depth they go. But for our purposes, for Tech Plus and even for A+, just know the subnet mask exists and move on. Don't look back, just move on, and you'll get that other stuff later, okay? So making your life easier, again, you don't need to memorize the numbers, but you should be familiar kind of with the range and just the general changes as far as the numbers from network to host, okay? That's all you really have to worry about from the Tech Plus portion. So a little bit easier. Okay, now Let's talk about that missing 127, right? I told you we were missing a number there. Well, 127.0.0.1 is a special type of address. It's called a loopback address or a home address. Basically, what you can do with 127.0.0.1, and everybody in computers knows this, it's like every Gen Xer knows 8675309. Okay, you don't know what that reference is, go ask a Gen X, we'll tell you. But we all know 127.0.0.1, okay? It's a loopback address. We are able to ping 127.0.0.1 as a basic networking troubleshooting thing, make sure we have TCP IP installed, make sure we got network card installed, make sure it's working, but it's a loopback address. There has been some funny merchandise made over the years. For example, a doormat, which you'll see later, that says there's no place like 127.0.0.1, which means no place like home. I had a shirt like that back in the day, but it's 127.0.0.1 is your loopback or home address. We also have private IP addresses. These cannot be used on the internet, and they go from a range of 10.0.0.0 to 10.0.255.255.255. We have the 127 group and we have the 192 group. I would suggest for the Tech Plus, not worrying so much about what comes after that first octet, but just recognizing if it starts with a 10 or a 172 or 192, chances are it's a private IP address. If you go on to more advanced networking courses, then you'll need to be more familiar with it. But again, from our purposes at this level, a basic familiarity and recognition is more than enough. Okay, so back in the old days, we had our internet, and we did not think for a moment, okay? We did not think for a moment the internet would become as big as it is today. Okay. Nobody back when this was created would ever think that we're going to have light bulbs that could connect to the internet, or security cameras or air conditioning units that could connect to the internet. And it was quickly discovered that we were running out of addresses. We were running out of IP addresses. So not everybody could have their own IP address. You couldn't just have your own IP address and call it a day. And so what wound up happening is we had to come up with different ways to circumvent these limitations. One such way was something called NAT, or Network Address Translation. So we said we have private internet addresses. These don't go on the internet. They cannot work on outside of your local area network. But they can work internally. They can work inside your network. And that's what we do. We give all the computers on your local network these private IP addresses that won't work on the rest of the internet. And you might be saying, but if they don't work on the rest of the internet, how are we able to get on the internet? Or you might be saying, well, I'm on the internet just fine. This is where the magic of NAT comes in. What winds up happening is, let's say you're home, your router gets that official IP address from your provider. It then gives all the devices on your local network private IP addresses. It just hands them out. We won't talk too much about how it does that. That's more advanced networking course. But it gives everybody on your local network a private IP address. And then, for example, you want to order a pizza. Actually, pizza sounds pretty good. You want to order a pizza and you go online. As you go through your own router, the router takes your private IP address, switches it with its official IP address that it was given from the company that you're paying money to, sends out that request for pizza. The request comes back, your router gets the request and says, okay, who initiated this communication? Oh, it was this one with a private IP address, swaps out the official IP address, gives it that private IP address, and sends it back to your device. So by having LANs and other networks being able to assign themselves their own private IP addresses, we don't need to use every official out in the wild IP address. So that helped out quite a bit and allowed us to continue to have internet. Okay, so this is called Network Address Translation, NAT. Okay, It also has a security feature built in, because with switching out IP addresses from private to your public, nobody knows generally what's going on internally. They don't know how many devices you have connected. And so it provides some privacy, some protection to the individual devices on your network. It makes it a little bit harder to go in and cause damage. Okay. So with IPv6, we have more than enough IP addresses. We'll never, ever use all the IP addresses for IPv6. This is going to be archived in 20 years, 30 years from now. Somebody's going to watch and go, look at this guy. He was so wrong. But with IPv6, we don't need NAT. However, you're still seeing it hang around because of that additional security that it offers, which is pretty cool. Okay. All right, speaking of IPv6, here it is, IPv6. The most current version of IP was kicked around back in the 90s, so it's taken a while for it to kind of really, and I just crashed PowerPoint. Of course, we have to do it at least once a session. Let me relaunch it here. Getting a little, oh, you broke it. I know. There we go. Oh, it relaunched on its own. That's kind of cool. Apparently my PowerPoint doesn't like working without coffee either. I think that speaks to a bigger problem. All right, let's try this again. All right, now we'll pop over here again. Question, 10 cell phones per house? No, I have never heard more than, right? Exactly. Alistair made a really good point. It's true. You know, a lot of things. I mean, the first personal computer, the very first personal computer didn't even have a hard drive. You had to load everything through a floppy drive. Okay. But the very first personal computers, it's amazing. Well, we won't never need that. We won't never need that. Who would ever use that to what we have today? Which makes us wonder what's coming in the future. Anyhow, back to IPv6. Nice vamping there while I was waiting for it to reboot. See, you all didn't notice anything. It's magic. Anyhow, so with IPv6, it was, like I said, it was kicked around back in the 90s. It's been always, oh, this is coming. It's going to be the next best thing. It's going to be great. It's going to be whatever. Well, it's finally kind of got its foothold now here in the 2020s. So still not as common as IPv4, but growing. We've been saying that forever. Designed to overcome the limitations of IPv4. So, for example, IPv4 was a 32-bit system, so you only had 4 billion IP addresses, while IPv6 is a 128-bit system with 340 that number of addresses, so quite a bit more. So, how are they written? You might be asked this on the Tech Plus exam. They're not going to ask you to write an IP address, but they will ask you most likely to recognize, if you see a bunch of numbers, what is this most likely, what it is, okay? So the IPv4 is written in dotted decimal notation. It looks like this, while an IPv6 address looks like this. It's written in hexadecimal. So just like all of us who were not good at math back in school, we were okay with regular numbers. But man, when they started throwing letters in there, it got more complicated. So hex is how we write this. And so if you see this or a variation of this, this is hexadecimal, and chances are you're looking at an IPv6 address. All right. Let's take a look now at internet service types. So we have something, and I said this earlier, we have something called an ISP. The ISP is who you're giving money to in order to access the internet. So it's kind of funny. It's kind of like AI right now, right? We hear about AI. Well, how do I get AI? How do I access AI? Back when the internet was first coming out, we heard about it. Well, how do you get on the internet? Do you just, where, do you just grab, is it floating around? Where's the internet? Well, to get on the internet, you had to go through AOL. Anyways, I'm kidding. AOL is actually a bulletin board system. Anyways. But to get on the internet, you have to pay a company, and they're an ISP. They're an internet service provider. And you might hear examples like Verizon, Fios, AT&T, Xfinity, Tacus. All of these are providers of your internet. They're internet service providers, or ISPs. In the old days, we would have something called dial-up. Folks would have modems. Originally, modems were not built into your computer. And then they came in expansion cards like you see there. And then they became integrated into your computer. And now they're gone. You can still buy expansion cards if you need, because there are places that still need dial-up connection. So modems would use the regular phone lines. You know, it's funny, when I was originally teaching this, I don't have to explain what a regular phone line was, but now this was the thing that you'd plug into the wall. Okay, it was a landline. So it would use your basic landline. You would call into your ISP provider. While connected, you couldn't use the phone. And if somebody picked up the phone, you would lose your connection. So that was the, hey, I'm going to be online. Don't touch the phones, and et cetera, et cetera. Back in the day, when I had my own business, well, I have my own business now, but I've always had my own businesses. But back in the day, we had two different phone lines coming into one of the places we lived, because I needed access to the internet on a regular basis, and it couldn't tie up the phone lines. And so we had two separate phone lines. And this was not uncommon, by the way, because one phone line people would use for the internet connection, while one phone line was for your personal communications. CompuServe was a dial-up as well. Yep. Oh, God, I remember CompuServe. We actually had, I want to say, I used to work at Best Buy on the tech bench before I became the Geek Squad. I want to say we had a CompuServe account back in the day, so we could dial the phones in. I'm not making this up. We did this is to dial up so we could download stuff on the computer. So if the computer needed an update, we would use that. It was, yeah. Anyhow, okay, Grandpa, time for some Advil and a nap. So dial-up is almost entirely dead. However, you might still run into it from time to time. So just be aware of that. So modem actually stands for something. Modem is not just a word on its own. It actually stands for modulate and demodulate. It would convert digital signals to analog and then back to digital signals. With dial-up, the modem would have to convert between the two. Newer technology still keeps the name, but they don't really need to modulate and demodulate anymore because, well, it's digital. So the name is just kind of stuck. All right, then, Alistair, no worries. Then we had digital subscriber line. This was a massive improvement over dial-up options. It was offered a complete digital solution, used the normal telephone lines, which was amazing, but had special equipment that allowed you to always stay on. So I remember when this first came out, we were living in Houston, and I remember the commercials for it. And the commercials were people were online, and then somebody pick up the phone and like, no, don't. And they were still online. It was amazing. It was faster than dial-up, noticeably faster. In fact, I started playing my very first online role-playing game called EverQuest, and it was so cool because you had fast internet connection, and the wife didn't get angry at you because you were tying up the phone line the entire time, which is really super cool. But that was called DSL, and we had two different variations of this called asymmetric and symmetric, or ADSL and SDSL. The ADSL had different uploads and download speeds. That's why it was it was, there it is, asymmetric. I forgot the word for a second. Again, blame the coffee. With ADSL, you can use your phone and be on the internet at the same time, while synchronous DSL had the same uploads and download speeds. It was much more expensive, and you had to have a special connection for it. So a lot of us would get the ADSL versus the SDSL, mainly because it was also, one was more available than the other, and one was more significantly less expensive than the other. So we've looked at dial-up and we've looked at DSL. Now, I will say this. If you're asked a question on the test about high-speed internet. Remember, DSL used the regular phone connections, okay? Just in case that shows up. It showed up in variations for the old ITF Plus certification. All right, moving on to broadband. This can carry your shows, your internet, and phone calls. This is faster than DSL, a lot faster. A cable internet required either an RG6 or RG59 coming into the house or office. So basically, you had your television, and you could have your internet, and it was all connected through this amazing kind of cable. Now, I will say this to the kiddies out there. At one point in time, we would have a phone company and we would have a cable company for TV, okay? And I still remember when we got our cable for the very first time. I was living as a little guy. I think I was in elementary school. And I remember when cable came out because, of course, you had MTV. That's how old I am. MTV was still playing music. Okay. And you had a cable company for the TV, but you had another company for your phone. Well, now look at what's going on. We don't have two separate companies anymore, right? The companies have merged. The phone companies got into the TV shows or TV providers. TV providers got into internet and phone calls. And so they kind of merged into just two communication companies. But back in the day, they were two separate entities altogether. All right. So that was cable. Next, we have fiber optic. Yep, skip DSL, went with at home. Yeah, I had DSL for a little while, mainly because the company who was providing it, I want to say they went belly up or something happened. And so it was very cruel, actually, because I got used to the high speed connections and then they went away and then I had to go back to dial up. And it was rough. I had to go through detox. It was bad. Not as bad as that scene from Train Spotting, if you know what I'm talking about, but it was rough. It was a rough go. So then we have fiber optics. Fiber optics used to be reserved for only those that could afford a very hefty price. This was incredibly expensive. But the prices for fiber have come down a great deal over the years. In fact, we finally have fiber at home, which was cheaper to get it than our Comcast was. Comcast, I remember, we went switching over to TACUS, and Comcast was like, "Oh, what can we do to bring you back?" It's like, well, you should have treated me nice from the beginning. Fiber is incredibly fast and secure when compared to its copper-based cousins, and it's, again, a lot more secure and a lot faster. Then we have satellite. Uses a satellite, I know that's kind of surprising, like the ones in orbit to connect to the internet. Download speeds are much faster than upload speeds traditionally. This is historically, and it's a good alternative for folks who can't get cable, fiber, or cellular service. Now, I will say this. The conversation around satellite connections is starting to change with Starlink and just the improvements. Satellite connections were only for folks historically who lived out in nowhere. I mean, they were considered lucky to have running water and electricity, okay? They only had dial-up because maybe they had a phone line, but there were no fiber optics going there. There was no cable going to those houses or that area. And so if they wanted anything faster than dial-up, they would have to use satellite. And I remember, again, this is years and years and years ago, I was working at Best Buy on the tech bench, and some marketing person was like, "Hey, we're going to start pushing satellite connections for homes, and you need to start selling it." And we're like, "No, we're not," because we're in Humble and Atascocita, and even though back then we weren't a major metropolitan, I mean, Houston's not far from us, but we still have cable connections out here. So it didn't last very long out here, I should say. Okay, now we have cellular. This is another one that's pretty exciting as far as what's going on. You might hear wireless WAN or WWAN, WAN, getting on the internet using a cellular device like a cell phone or cellular hotspot. Again, this used to be kind of a last resort, or you were on the road or something, but this is becoming more and more viable as an alternative to other solutions that we just talked about. You might hear 4G and 5G Users, like I said, can replace their wired networks with cellular service. So this is going to be interesting to see how this goes. Maybe we're going to be talking one day, not about the cables coming into the house, but your cell phone service. So comparing distances, you don't need to memorize this, but you should know in order from how far out something can go to the closest. So we have satellite. That obviously is the largest distance because these things are in space, right? Then we have fiber optics. We have cellular. We have unshielded twisted pair cable we talked about during the networking fundamentals part. You got the 802.11. We got our Bluetooth. We got infrared. And finally, the smallest itty bitty distance is your NFC. That is your smallest distance to connect. That's what you use to like pay on your phones and things like that. Okay. So you won't be asked the specifics on the exam, but you should definitely know, for example, which is the smallest distance of all of these types of connections. Okay. All right. Let's talk about the internet. So the internet, this is a real quote from a senator. It's a series of tubes. This is an old quote. Not really. It's not really a series of tubes, but it's the most well-known WAN. It is a massive system, a massive, humongous system of connected computer networks. The internet uses the TCP/IP protocol suite. Now, the TCP/IP is a protocol suite. It's a whole bunch of different services that make up the internet. The internet is not just the World Wide Web. The internet is made of a whole bunch of different things. So the World Wide Web is part of the internet, but it's not the only thing. You've got email, you've got streaming media, you've got all sorts of things that are part of this protocol suite, including some things that are so old that, I don't even think we have to worry about those in more advanced networking courses because they have been retired for quite some time. So quick little history for you. And it's funny because we're seeing some of this repeating right now, okay? It traces its roots to ARPA, the Advanced Research Project Agency. It was founded in 1958, partially in response to the launch of Sputnik. Now, let me share this with you. If you took a high school history class, right? If you were in high school history, you learned about Sputnik. You were told, right, that Sputnik kicked off the space race. Well, that's partially true, okay? The space race was really just a race to get rockets and rocket technology, because if you have a rocket that could go into space, you could put a nuke on it and send it to anywhere in the globe, okay? But what happened is not only did Sputnik scare the Americans like crazy scared, okay? Caused this whole big scare. Not only did it kick off the space race, but it kicked off all these other research projects, including this whole ARPA thing. So from the launch of Sputnik, we saw a major interest from scientists and the military in developing this networking technology. Okay, so that gave rise to all of this. So in October of 1969, two nodes were connected, thus creating ARPANET. The ARPANET is the granddaddy of the internet. This is what came first. The nodes were at UCLA and SRI, if you're interested. And the first use of the term internet was in a publication back in December 1974. Now, the reason why I'm saying we're seeing some of this right now is if you look at AI. And I'm not going to go too far down this rabbit hole because we have a lot to cover, but I just wanted to talk about this one brief little point, which is AI, as you know, right? They're in a race, right? You've got ChatGPT and Claude and Grok and Gemini and some of these other ones. And they're in a constant race to see who can release the newest model, who can be better than who, whatever, right? What most people aren't aware of is we're not just seeing a consumer race for AI to see which dominates the market, but we're seeing a national race. Okay, just like the space race was also a race to develop rocket technology because the people who can put nukes on rockets win. We're seeing an AI race because the country that dominates In the world of AI, okay, you don't want to be the country out there who your entire defense and security and protection, you don't got work in AI, or everybody else's AI is more superior to yours, because you're going to have a bad time. So just like we saw the space race and the creation of the internet through ARPANET and all this other stuff, we're seeing a race right now, a global race between countries on becoming the dominant force of AI. Just a total side note for you, which, by the way, we launched our AI newsletter last week, and our podcast last week, also found on the StackFord YouTube channel. So if you're interested in AI, be sure to check that out. But again, don't want a rabbit hole here. So back to the internet. So the internet's just a bunch of rules. Most folks might think that the World Wide Web is the internet. Like I said, not exactly. The internet is made of a bunch of protocols or rules, and these are the ones we need to be aware of for this certification exam. We have the Hypertext Transfer Protocol, or HTTP, and if we add an S to the end, we wind up with the HTTPS. That is the secure version of this. We have something called File Transfer Protocol, or FTP. We have something called SMTP, otherwise known as Simple Mail Transfer Protocols. We've got POP, which stands for Post Office Protocol, and IMAP, which is Internet Message Access Protocol. We got DNS, which is Domain Systems. We've got DHCP, which is Dynamic Host Configuration Protocol. And we've got HTML, which is Hypertext Markup Language, and CSS, which is Cascading Style Sheets. So that is, we go into this in a little more detail. Okay, so here's a little bit more detail on these different protocols. Looking first at HTTP and HTTPS. This is the core of how the World Wide Web works. It's found in OSI Layer 7. It allows linking of items to each other. So this is pretty cool. It allows linking of different things. It creates this web. Hey, I wonder if that had any reason why we call it the World Wide Web, but it creates these links that can go to other links that can connect to other things, et cetera, et cetera. And like I said, HTTPS is the more secure version of this. Back when HTTP ruled the playground, Google and some other providers were like, look, HTTPS is much more secure. Things are getting scary, dangerous out there. People are using bad sites, fake sites, et cetera, et cetera. And so Google, who, I mean, let's be honest, is the king of the internet, right? They were like, if you want to rank higher on our search results, you need to use HTTPS. It wasn't forced. It was just kind of a stick and carrot, but kind of a carrot with very obvious messaging, which was, if you want anybody to use your site, you're going to use HTTPS. And they gave people quite some time to adopt and change over to HTTPS. Well, now browsers, if you try to go to an HTTP site, your browser is going to scream at you, metaphorically speaking, because they're like, this is not secure, this is not secure, this is not secure. Okay. So HTTP is your more secured version. Then we've got FTP, File Transfer Protocols, which is used to send computer files from a server to a client. This is how us old web developers or web designers used to upload our web pages. We used to have to play with them locally and then upload them to a file somewhere on the internet. And FileZilla is a popular and free FTP program. Then we got SMTP. SMTP is the protocol that allows you to send emails. Now, let me clarify this. Emails have two different protocols. One protocol to send the email out, one protocol to bring the email in. Now, there's two variations of that, but one to go out, one to come back in. I personally remember, and it's not correct because the S stands for simple, but I always think the S stands for send. Okay, I like to think of the S for send. So SMTP sends the email out. Then we've got two options to receive the email. We have POP and IMAP. The big difference between these two is what it does with the emails from your email server. If you use POP, it will download all the emails to your local machine, which means the emails can't be accessed on another machine. While IMAP, it still stays on the the email server. So let me explain this. I have my laptop. I've got Outlook. If I go home, I also have Outlook there. I can access my emails here on my computer, my laptop in front of me. I can access the emails on my laptop. I can access emails on my phone, okay? The emails are still there. That is IMAP at work. If I was to use POP and I opened up my emails on my laptop, all the emails would be downloaded to my laptop. So if I open my phone later, they're not there. If I go home and look at my email there, it's not there. So IMAP leaves the emails on the server while POP downloads them. Then we've got DNS. Websites are not found on the internet by their fancy names. For example, StackFord.net, wonderful, wonderful site, by the way, it is not how your computer sees it. It's got to translate your domain name to an actual IP address. It is through something called the domain name server, which allows us to get to where we need to be. Yeah, send is too simple. Absolutely. All right, then we got dynamic host control protocol. Remember I said earlier that your router will assign you your IP address? Well, it does that through something called DHCP. It allows your server or your router or a DHCP server on its own to assign those IP addresses on its own. Okay, so DHCP gives out the IP addresses to the devices that are connected to them. In more advanced networking courses, you discover that there are default IP addresses that your computer will use if it can't access a DHCP server. That's a whole other conversation. Okay. So quick water break. Ugh, water. I think I'm going to send this video directly to Regis and say, fix your coffee machine. All right, let's continue on and look at networking software utilities. So there's actually quite a bit of software utilities that help you check the status of your network. They're built into your computer. So for example, you can find these utilities in Windows, you can find them in Mac OS, you can find them in Linux, and depending on what operating system, their names might be a little bit different. So the first one is something called ipconfig or ifconfig. Ipconfig is what you find on a PC. Ifconfig is what you're going to find on your Mac OS and your Linux. Okay, so ipconfig is a utility that displays important network configuration information. You can find your IP address there, your subnet mask, your MAC address. If you remember MAC from previous live streams. If IP address we're thinking of it as your phone number, think of MAC address as your social security number. Okay. So that's ipconfig. Again, like I said, ifconfig is a terminal version. You find this on Mac OS. You find this on Linux. I want to introduce something called a switch. A switch is additional commands or additional conditions you can give your commands to do different functions. So for example, with ipconfig, if we do a /all, it displays all that information. If we do a /release, it's going to give up the IP address that's on your computer. Sometimes you need to do that. If you do a /renew, it's going to renew that IP address. If you do a /flush DNS, it's going to get rid of what's cached on your computer for the DNS. That's helpful if you might have a DNS injection or you've got bad DNS on your computer. You can clear it out. And always, 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 always a /? Will bring help. It'll give you help on whatever command that you're using. Okay. If we were in a face-to-face class right now, I'd be having you bust out your computers and going into your command prompt and trying this out yourself by going into command prompt and typing ipconfig /all, finding the MAC address, finding your IPv4 address, all of that stuff as well. Okay, so this is what we'd be doing in a face-to-face class. So you can see right here, here's an example of what you would find in person. By the way, if you're a computer teacher, taking screen captures as videos and exporting them as GIFs is so incredibly helpful because students can see what you're doing over and over again and not get too lost. All right, then we got ping. Ping is a basic utility to see if, you can reach your host, if you can reach where you're going to. So you can send a ping. It's a single ICMP echo request, not important, but it's a itty bitty little request that gets sent to a target. And if the target is online and it sees your ping and it's set to respond to the ping, it will send you information back. It'll say, hey, I'm here. This is helpful because maybe a website doesn't quite work completely right. But if you ping them, they're actually there. So they may have other problems as well. It's the same command in Terminal and Mac OS, although you have to tell it to stop. Otherwise, it'll keep pinging. Again, you remember what 127.0.0.1 is. That is your home. That's your loopback address. So you should be able to ping that without a problem. Even if you're not connected to the internet, then you can also ping YouTube or Google and see what comes back from there. So, for example, here we are pinging 127.0.0.1, and we get a reply. Then we have traceroute, or as I call it, tracert, because that's how we put it into a Windows computer. A traceroute gives you a lot more information. A ping is a fast and quick way to see if the host is there. A traceroute will actually go from router to router to router to show you the entire path that you take from your device to your end target. Okay, so this is very helpful. For example, let's say you're dealing with Comcast and they're saying that the problem's not on their end, the problem's on your end, and you can trace route out of your house to their router or outside, and then it dies. You know where the problem is. Not that that's ever happened to me. Of course, the terminal version is actually called traceroute, which you can see there in the animation, just what we're seeing, right? You can see all these different hops, that's what we call them, of the different routers that you go through. Here we go. You can see it live in action, well, sort of live. Trace routing to YouTube. This does take a little bit longer than a ping request. That's the reason why we did a time fade there, which you can see right there, okay? Then we got a netstat command. A netstat command is used to display active TCP or UDP connections, as well as a host of other statistics. We talked about TCP and UDP in our networking fundamentals live stream. Basically, TCP is a good parent who tells the kid, hey, text me when you get there. UDP is like, I don't care. Hope you get there, but I'm not checking up on you. Okay. If you type in netstat space -an, A shows all active TCP connections and the ports that the computer is listening to, while N shows active TCP connections. So this is going to list all the doors that you have that are listening to networking traffic. Now, again, if we were in person, you would be doing a lab right now showing you how to do this. Now, I will give you this one important safety tip. Bad guys, some scammers will call in or try to scare people and say, hey, you know, we think you're being hacked and we need you to type this command in. And they're going to tell the victim to type in netstat. Well, the person who's not a networking person is going to see all of these things that show open or listening, and they're going to freak out because they think they're being hacked. They think all these things are looking into their computer. And of course, the bad guys, right, will tell them, well, we can close this out for you, but we need a gift certificate from Walmart or Amazon, so we need you to go shopping. So these bad guys, I'm telling you what. All right, so that is the basic stuff there. Let's talk about web browsers. So quick history of the World Wide Web, invented by Sir Tim Berners-Lee in 1989. Like I said earlier, the World Wide Web is part of the internet, but not the entire internet. It's one of many standards we already took a look at. And it's a way to share and access information in a more user-friendly format, i.e. graphical. And it was the World Wide Web that really made the internet just blow up, because the internet was there before the World Wide Web. But it was text-based. It was boring. You had to do Archies and spiders and all sorts of other things. And people were like, it's geeky stuff. The World Wide Web gave a face, gave a graphic user face. It said, hey, it's warm and fuzzy over here. Come on, join us on the internet. And so that's what the World Wide Web provided. And we have things called web browsers. Web browsers allow users to interact with the World Wide Web, i.e. the web. It's a graphical face, like I said. And we've got different browsers out there. So for example, in this graphic, we got Google Chrome, we got Firefox, we got Safari, and we've got Tor. We have something called a URL. URL websites are found through their Uniform Resource Locator. The URL is a web address of where you want to go. The URL is composed of at least the following elements. You have a protocol, your domain name, and a path. Let's take a look at these in a little more detail. Now, we're not sponsored by Bones Coffee, although I would love to be sponsored by Bones Coffee. One of my favorite coffee places. They're located in South Florida. They've got some amazing coffees. Wow, I'm really getting too attached to that right now. Again, coffee machine broken. But Bones Coffee is our example. The first part is the protocol, right? The protocol is HTTP or HTTPS. This establishes the rules for how we're going to send information back and forth. Okay, so the protocol establishes the rules. It's the protocol of how we're going to send information to and from. Then we've got the name of the site. This is the thing that you buy from a domain registering service or some web hosting company, and that is the name of the site. And this one, it happens to be Bones Coffee, okay? And then the tail end is something called a top level domain. At the end of every domain is a something like .com, .edu, .net, .org, and more. These are known as top level domains. And what they do is they tell your DNS where they need to go looking, okay? So originally, there were only the following top-level domains. We had .com, we had .org, .net, .edu, .mil, and .int. Now there are over 1,000 of these things, okay? Again, we've had an explosion of not just internet, things, but we've had an explosion of web pages, and we just run out of places to put them. So the Internet Corporation for assigned names and numbers, ICANN, is responsible for creating new top-level domains. So we have the generic. This means anybody can register these. Anybody can create a .com, a .org, a .net site. There's nothing special about these. Anybody can make them. Then we've got sponsored ones. Sponsored ones require you to prove that you belong in this space. So for example, an EDU space is education. If I, for example, like StackFord, right, my company, we provide training and educational services, but we're not a school. We're not a K-12. We're not a college. We're not a university. And so we can't get an EDU domain, because if we applied for a domain, we'd have to apply for this. We would have to show proof we're a school, we're an educational institution. Same thing with, for example, .gov. We would have to prove that we're a government body, we're a government agency. So these require some sort of proof to go with it. Then we have country codes. These are based off of the country the site is in. So for example, US, UK, JP. Then we got niche domains, for example, .ninja, .coffee, .tech, .art, .guru. Now, here's some fun trivia for you, okay? Ever hear of this country? I never heard of this country. Well, you might never heard of the country, but you've heard of AI, right? Well, we say AI. Remember I just said country codes? Well, guess what? That country's country code on the internet is AI. So this small little Caribbean, British overseas territory, this little place, okay, I think it would take me longer to drive from one side of Houston to the other side of Houston than across this entire country, okay? This little country happens to have the country code of AI. Well, all these companies are buying domains with .ai, all right? They don't want it to be a country code. They just see AI, and so they're buying it, buying them. This is wild. AI registrations that account for, they're making millions of dollars off of AI registrations. It accounts for 20 to 23% of their government revenue. How wild is that? I thought that was just so cool. Anyhow, pretty neat. All right, so moving on. Now we have something called hypertext text markup language. This is the programming code of our websites, okay? This is how websites are coded. Oh, you've got this there, you got this picture, you got this words. That's done through HTML. It's a traditional method for coding websites. Now, there are other languages that play with websites, but HTML is the main one. It's had multiple updates over the years, adding functionality, with HTML5 being the current iteration. If you take a look at the image here, we have a CompTIA site. This is what you see, right? This is what you're looking at. But over here is what's providing that stuff over here that you can see. Kind of cool. Then we have web browsers. I said that a second ago. We got things like Apple Safari, Brave, Google Chrome, Microsoft Edge, Mozilla Firefox, Opera, Tor, and Vivaldi. And it crashed again. I am loving this. Give me a second while that reboots. Come on. It is wild. There's something about, I don't know why, but there's something about live streaming with PowerPoint that just sometimes it crashes PowerPoint. And I don't know why. Not that I've really spent a lot of time researching it, but it's just interesting because it doesn't crash otherwise. So there's some sort of interaction. I got OBS running in the background, but it's interesting to me. Anyways, moving on. So several web browsers. We have Apple Safari, like I said, Brave, Google Chrome, Microsoft Edge, Mozilla Firefox, Opera, Tor, and Vivaldi. All of these browsers have different things that they have claims to fame for. Things that, oh, we're different because we do this. We're different because we do that. I know Firefox, I think it is, or DuckDuckGo is really pushing the fact that they have no AI options. Google Chrome has really kind of embraced AI, whether you want to or not. Some say they're killing the internet, but that's a whole other conversation. So tech tip. You saw the Tor website or web browser there. Tor browser is specifically designed for the dark web and privacy. The dark web is called the dark web because it's not indexed by search engines. It's kind of this hidden underlayer of the internet, which, to be frank, if you don't know what you're doing, don't go there. Google is jealous, right? Don't go to the dark web unless you know what you're doing, unless you know what a VPN is. Again, this is not something that you should play around with. Now, if you go into IT and you go into networking, you know, we got to learn the tools and we got to know what we're doing. So that would be something else. But if you're a casual person, you're just learning about technology, don't install Tor and don't go to the dark web. I am not responsible for your nightmares. All right. So then we got some basic configuration stuff that we need to be aware of when we're dealing with web browsers. Okay. So we need to know about caching and clearing your cache. We need to know about deactivating client-side scripting. We need to know about working with browser extensions, private browsing, proxy settings, certifications, or certificates, I should say, and pop-up blockers. So clearing your cache, when you go to a website, it's going to store some stuff on your computer. It's called the cache. This is left over from the old dial-up days because it made your connections faster. Remember, dial-up was slow. And so if you downloaded pictures from the web page that were built into the web page, you'd have to do them again. It made things faster. But too much cache files can cause slowdowns on your computers. So you can clear out the cache on your computer. Clearing the cache in Chrome, you can see there what's going on. And all browsers have it. You just need to find where they particularly hide it. Okay. Then we got client-side scripting. Have you ever gone, okay, get ready for some hacker tools here. I'm only kidding. Have you ever gone to a website and they block you with a paywall, right? If you go to a news site, for example, they're notorious for this. They go, oh, you must, pay for blah, blah, blah articles. If you disable this, it goes away. It goes away, it goes away, it goes away. So client-side scripting, it's designed to really make your web browsing, your experience more enjoyable, to give you more interactions. Well, those paywalls, those news sites are using this client-side scripting. So you turn it off and it goes away. Now, that's one use that we can use this for, but the bad guys can use client-side scripting to attack your computer And so there might be a reason you need to turn this off or disable it. So here in Chrome again, we look at launching the Chrome. You go to accessing your settings. We're going to go down to our privacy and security. We're going to go to site settings. And for this one, we're going to look for JavaScript and we're going to turn that off. Okay. Again, if you get blocked by paywalls on news sites, you can use this. Then we've got browser extensions and add-ons. This adds additional functionality to your web browser. So for example, I use Claude. I also use ChatGPT. But with Claude, you can actually put in browsers that allow ChatGPT to kind of act through your website, through your web browser, which is pretty interesting. Other things, for example, I've got Grammarly on my web browser that helps me with my spelling and grammar. You can have search engine optimization, but these add additional functionality. Think of like modding a game, okay? But they're in your browser instead. Private browsing is not that private. I will start off the conversation like that. Okay, browsers introduce something known as private browsing. People are like, oh, I'm finally private. No. It has a use, but it's not as private as you think it is. Google calls it incognito, Edge calls it in private, and Firefox calls it private windows. But again, it's not as private as people think it is. People got fired because they're at work and they go, oh, I'm going to go private browsing. And no, we still know what you're doing. Okay. Now, some of the features are really cool, however, and I use private browsing from time to time, especially as I'm developing stuff. So if I want to see how something looks, without any cache or without any kind of stored information. For example, very helpful when you're working with an LMS or you want to look at a web page without being logged in. So I'll do some web design. I want to see how it looks to somebody that might be coming there fresh. I'll use private mode a lot. Okay, so it's very helpful in certain situations. I would say more development than anything else. So some features of private browsing is it doesn't keep track of browsing history on your device. It prevents a search history. It stops form data and passwords from being saved. It blocks or reduces cookies from being stored, stops cache files, and creates a different session. To me, this is where this is worth the money, is it creates different sessions from your other browsing windows. So I can be, for example, in my Moodle site for my StackFord, in multiple different private browsing instances, and they're all considered separate sessions. So nothing's carried over from one to the other. So I can make a change and see instantly how it works. Also, let's say you have a problem logging in somewhere. Let's say you have a problem logging into a website. Try doing it through private browsing and see if that clears up the problem. There might be something stuck in your cache that's causing the issue. I've had to do that before in the past with banking and school access to grades and stuff like that. It was weird. Then we got proxy settings. Proxy servers act as a gateway for users to get to the internet. You can set specifically proxy server settings on your computer if you so choose. Certificates. This establishes trust connection between you and the website you're going to. Certificates can be verified by third-party vendors, or the web page itself could issue a certificate. Untrusted certificates can be fine or used to trick users. If you are using a website and it does have an uncertified certificate, the alarms will go off on your browser. I was doing a training in San Antonio, and we were working out of the Goodwill Academy or Goodwill University. They had their own homemade certificate. Every time we tried to access it, it was giving us warnings on our computers. We had to accept the risk, all that fun stuff. Then we got pop-up blockers. Pop-up blockers block pop-ups. Okay, it used to be a huge problem back in the day. You go to a website and things would pop up in front of you, or you could have pop-unders, which is they pop underneath your browser. So when you close out your browser, there it is waiting for you. Okay, that is our pause point. That is the end of our conversation about WANs, but we're not done yet. Okay, we're not done quite yet. We're going to switch gears. We're going to switch gears because it's time for Kahoot. Okay, let me tell you how we do this. For those of you who are new, I'm going to throw up the Kahoot page for you. It's going to give you a PIN number, or you can scan the QR code. So let's get ready to play some Kahoot here. Here it is. You can join the Kahoot game by going to kahoot.it, putting in that PIN number, or scanning the QR code. There is a time delay between what I'm saying and this, so I will give you guys a few minutes to jump into the game. As you're playing the game, be sure to check your computer or your phone because that'll have the current question you're on. So scan the QR code or go to kahoot.it and join the game. Come on, folks. Come on and join. Scan the QR code or go to kahoot.it. When we're done with this game, it's about 10 questions in there. Then we'll finish off with virtualization and cloud computing. We'll wrap it up with one more Kahoot game. I know we went a little long in that first section, but there was a lot to cover. All right, we're going to hop into the game now. You can join the game while we're going through by scanning not scanning the QR code, but putting the PIN number in. So here we go. Part 1. First question, what does WAN stand for? What does WAN stand for? Wide area network. All right, Crafty Gull takes the lead early on. Question number 2, what type of network covers a large geographical area? Remember, points are awarded for right answers and quickness. What type of network covers a large geographical area? Geographic area. Remember to keep an eye on your phone or your computer while you're playing. Don't watch the live stream for this. There is a delay. That would, of course, be the WAN. Everybody got that one right. Awesome job. All right. Phenomenal Lemming taking the lead. Question number 3. What is the main job of an IP address? What is the main job of an IP address? I told you you're going to see that format, by the way. It is to identify a device on a network. It's your device's phone number. All right, next question. Selling-based game, we got double points hidden throughout the thing. Speaking of double points, here we go. Which IP version uses addresses like 192.168.1.25? That would be IPv4. Crafty Gull taking back that lead. Question number 5. Why was IPv6 created? To provide more IP addresses. Absolutely. Everybody got that one right. Good job. Next question, question number 6. We still got double. Oh, here's a double point question. What does NAT help a network do? Translates private IP addresses to public IP addresses. Everybody got that one right. Looks like we had a new player join us. Welcome, welcome, welcome. Next question, question number 7. Which protocol helps match website names to IP addresses? DNS. Everybody got that one right. Awesome job, y'all. All right, next question. Question number 8 for double points. Which command checks if a device is reachable on a network? Ping. Everybody got that one right. Good job. All right, Crafty Golf still maintaining the lead. Question number 9. Which command shows the path data takes to a destination? Don't forget, we'll have another Kahoot at the end of the night. We still have virtualization and cloud computing to cover. That would be traceroute. Excellent. Everybody got that one right. Good job. Question number 10. Up, Geek Alert. In Futurama, what is the name of the delivery company where Fry works? Always like to end our Kahoots on an unrelated geek kind of question. Planet Express. All right, let's see what our final scores are. Coming in third place, Aquatic Cat. Coming in second place, Phenomenal Lemming. And coming in first place, Crafty Goal. Excellent job, everybody. All right, good job. We still have one more Kahoot to wrap up the night, but that was cool. We're going to hop into the rest of our conversation. Let me load up our virtualization part. Okay, so we have virtualization now. The older ITF Plus exam used to really eat my students' lunches when it came to virtualization. The exam, I think, has gotten more reasonable, but you need to know the basics of virtualization. So here we go, okay? First of all, what is virtualization? Virtualization, if you think of the Matrix or the movie Ready Player One, it creates a virtual environment for different programs and resources to run in. Virtualization is a technology that enables the creation of virtual versions of computing resources. Basically, it allows you to create virtual computers in another computer. Okay, so you're creating these virtual environments within an additional computer. Okay, to make virtualization work, we need 3 things. First, we need computer and hardware. The computer will provide the necessary resources to run the virtual machine. So it's going to provide RAM, it's going to provide CPUs, it's going to provide storage space. So we need a computer and hardware to run the virtualization. Alistair, good job. I'm assuming that you, by the woohoo, you won. Good. A hypervisor is the program that runs the virtual machine. It creates and manages the shell that runs the virtual machine. So hypervisor, VirtualBox is an outstanding program to do virtualization. I used to use it extensively in the classroom and in training because it's a free program that allows us to create virtual machines, virtual computers running Windows 10, 11, whatever, okay? VMware is another example of a virtualization program that allows you to run virtual machines. But VM or VirtualBox are all called hypervisors. A hypervisor is the program that runs the virtual machine. Nothing worse than missing a question because you didn't know what they were calling it. So hypervisor is the program that runs the virtual machine. Now, let me give you a little teacher insight. I said hypervisor multiple times there. When I say something multiple times, it's not because I'm stuck on what to say next, okay? It's because these are terms that the tests really love you to know. So, hypervisor, okay? Then we have our guest operating system. The guest operating system is nothing more than the operating system you're going to run on the, what is it? the hypervisor. Okay. So the three things we need, once again, for virtualization to work is your computer hardware. It's going to provide the power, right? It's going to provide the base on which everything works, the memory, the RAM, all that stuff, or memory is RAM, the RAM, the CPU, all that stuff. Hypervisor is the software that runs the virtual environment, while the guest operating system is the program that you're running, right? It's the virtual machine. Like I said a second ago, VirtualBox is an outstanding tool. If you're going to get into IT, I highly suggest you download a copy of VirtualBox. I would go online to YouTube to do tutorials on how to install things because things change and it's beyond the scope of what we're talking about. But VirtualBox allows you to run examples of Windows 10, Windows 11, Windows 8, 8.1, 7, whatever. It allows you to run versions of Linux distros. It allows you to run these things. Most importantly, allows you to play around with them. So you can change administrative settings in a virtual machine without worrying about messing up your computer. Okay, so highly recommend for those of you who are learning about computers to get yourself a copy of VirtualBox. Like I said, it's free. All right, so at this point, hypervisor, you are familiar with the word, I hope, okay? So hypervisors, virtual machine monitors, are hardware or software platforms that create and manage virtual machines. And there are two types of hypervisors we need to be aware of. The first one is called Type 1 hypervisor or bare metal hypervisor. The second one is called Type 2 hypervisor, and that is a hosted hypervisor. Now, don't worry, this will make sense in just a second. The Type 1 is known as a bare metal hypervisor. The hypervisor is installed directly on the computer, interacts directly with the hardware. So the hypervisor is the program that's going to run this virtual universe that operating systems are going to get plugged into, okay? In a Type 1, that hypervisor is interacting directly, right, with the underlying hardware and the computer itself. Okay, so it is there sitting right on the hardware. It's interacting with the hardware. It's very robust. This is what you find in enterprise solutions. This is what you're going to find, for example, if you're running an Amazon web server, virtual machine. These are robust. They're powerful. They are meant to run multiple operating systems, guest operating systems. The Type 2 hypervisor is known as a hosted hypervisor. This runs as an application within a hosting operating system. Now, let me explain this a little bit easier. The Type 2 is what I had to do in the classroom. We had all these classroom computers, and they all had Windows 10 installed on them. We had to download VirtualBox. It's a separate program. We would have to install VirtualBox just like any other application into that Windows computer. So we would install VirtualBox just like any other program. Okay. We would have it run through the Windows computer, and it would sit on top of the Windows computer that was already installed. So Windows, the operating system running that computer, would manage the hypervisor. It would manage the VirtualBox. Now, as you can imagine, because we have all the hardware is already having to run the operating system built in. The operating system is running this this hypervisor. It leaves less resources for those guest operating systems. So that is a Type 2 hypervisor known as a hosted, because you're hosting it on a different operating system. Okay. They're not as robust, obviously, but they're great for example, for our uses of playing around and seeing what's going on. Okay. That is all you need to know about virtualization. We're going to talk about cloud computing in a minute, but that's all you need to know about virtualization. I cannot stress this enough for that certification exam. Know what the three things are that you need to run a virtual machine. Know what a hypervisor is. If you don't wake up at 2 o'clock in the morning, you're sleeping, hypervisor, then I have not done my job. Okay. So hypervisor is the program that is going to coordinate that guest operating system. Know these. Know the difference between type 1, type 2. Know what they're also called besides just type 1, type 2. Okay? The exam, I guarantee you, is going to ask at least 1 or 2 questions off of this material. Don't miss those questions. Okay. Let me grab some water here as we get into our cloud computing. All right. So cloud computing. Users and organizations can access resources over the internet. This used to be a relatively foreign concept. I used to have to talk about this Gmail, which was still in beta testing at the time, as an example of cloud computing. Now, cloud computing is so ubiquitous. I would say my workday is about 50-50. 50% I'm working on something local, 50% I'm working on the cloud somewhere. So cloud computing is we're working somewhere on the cloud. We're not working locally. We're working on somebody else's computer somewhere else, okay? So instead of a user or organization buying their own additional equipment, they can pay other providers to give them access to online storage, processing infrastructure, and more. There are 3 types of service models we need to be aware of for the Tech Plus exam. The first one is infrastructure as a service, okay? This provides virtualized infrastructure resources over the internet computing resources. Users and organizations can run virtual machine storage and other infrastructures, for example, Amazon Web Services. Let me explain what I just said. Okay, so I have a Moodle site, okay, through StackFord, which is the company that we sell curriculum through, which, by the way, the best Tech Plus Principles of Information Technology curriculum in the country. Anyhow, but we have a Moodle site. The Moodle site only allows us so much storage space. I need more storage space. I have all these files, movies, videos, e-learning, labs, simulations. I got a ton of stuff that I need students to be able to access. But Moodle severely limits me on, especially the hosting I have, it limits me on how much it will take for storage. So I need infrastructure. I need some place to store this. Amazon Web Services. It's a whole bunch of different services. One of the services I have is basically a storage online service. And so when I publish my videos, when I publish my e-learning, when I publish lab sims and simulations and digital worksheets and everything else we're doing, I don't put them directly on Moodle. I put them in this storage area on Amazon Web Services. It's infrastructure. Basically it's a storage server that I access through the cloud. I don't have an additional server in this office with me, okay? And I don't want to buy a server. I can't afford a server. These things are expensive, okay? If you remember previous videos, its own operating system, all sorts of things. So I'm going to use infrastructure as a service. I'm going to hire another company to provide storage for me. I also got to play around with Amazon Web Services, which, by the way, you can play around with relatively inexpensive. As long as you go into production, you're good. But if you're going into IT, you might want to get an account now and explore it at your own time, okay? So infrastructure as a service allows us to have this infrastructure, allows us to have servers, allows us to have storage space, all this stuff. Then we have platform as a service, platforms over the internet. Platforms can take the form of development tools, services to create, launch, and manage applications. Examples under platform is Google App Engine, Microsoft Azure App Services, and Heroku are 2 great examples. And finally, probably the one that I would assume everybody here, well, no, I'm not going to, I guarantee you know what software as a service is. I guarantee you know what software as a service is. You know how I know that you know that you know that I know that you know what SaaS is, software as a service is? Because you're on YouTube right now. You're watching this live stream through software that's not installed on your computer. Oh, look at that. Even without coffee. Boom. Okay. It's the software as a service. It's software that's not on your computer. It's stored on the cloud somewhere that you're accessing. So software as a service is accessed software through a web browser like YouTube. Some Prime examples of software as a service, SaaS, includes Microsoft 365, Google Workspaces, and one of my favorite project management tools, Monday.com. Okay, so those were the three services that we had to be aware of. Now we're going to try to wrap up here by looking at cloud deployment models. Okay, I'm going to try to make this as clear as possible. It's really not difficult. If you get caught in the terminology, I'll explain it in just a second, like I've done this entire evening. Okay, so cloud deployment models refer to the methods by which cloud services are made available. So we looked at SaaS, we looked at platform as a service, all these other things. Now we're looking at how you get access to them. How are they available to you? Okay, so we're looking at who manages them, who owns them, and how they are accessed. There are 4 types of deployment that we need to be aware of for this certification exam. That is public cloud, private cloud, hybrid cloud, and community cloud. Quick little word on this one. On-premise is also known as private cloud. Cloud might be called public cloud, and hybrid is called hybrid. So that's what the Tech Plus might ask you to know them as well. They do not mention community cloud in their testing objectives, but when we talk about it, it'll make sense because it kind of wraps up everything, okay? So public cloud is a third-party provider like Microsoft or AWS. Hosts these, anyone can join them, and their resources are shared among multiple users called tenants. Just like an apartment, you're a tenant in an apartment, okay? Now, this doesn't mean that you get access to everybody else's things. So, for example, a public cloud would be YouTube. A public cloud would be your Gmail account. Anybody can use YouTube. Anybody can use Gmail. It's there. But that doesn't mean that if you have a Gmail account, everybody gets access to your Gmail account. They're separated from each other. So tenants have their own access, their own private information, but anybody can use these services. That is a public cloud. The opposite of a public cloud, the exact opposite, is something called a private cloud. This is a single organization, an organization. Man, that lack of coffee is starting to really kick in. A single organization uses the cloud infrastructure. The organization or a third party could own the private cloud. The cloud could be hosted on premise or in a data center. These are highly secure and under the control of a private cloud's owner. So let's say, for example, you are an organization that has offices everywhere. You don't want a public cloud, but you want a private cloud. You are paying, maybe you have your own data center, or maybe you're paying another party to maintain its separate data and separate servers. It is completely separate from the public cloud. It is, you're paying for this private access, you're paying for this private thing. So for example, the government, right? The government's not going to have, well, I don't know, maybe, but the government shouldn't have this thing where anybody can get access to the servers and just separate it through tenants. You're going to have probably your own private data centers with your own private cloud setup. Okay. So that's your private cloud. Then we have a hybrid cloud. This is a combination of a public and private cloud setup. For example, an organization might want to utilize private cloud functionality for sensitive data, but also have a web application that resides on the public cloud side. So they might have both a private and a public facing cloud where people can access the public cloud, but the private cloud is them internally only. Then we might have a community cloud. Community clouds can be expensive and require a significant amount of money and overhead to manage. A community cloud might combine organizations with a common need. So for example, I got to go to UT at their supercomputer. I'm not sure if this is what they have set up, but I'm using them as an example-ish. All of these different organizations could dial in to their supercomputers. I'm sure they're paying them because I'm sure UT's paying for that and they're paying for that. But you have this community that might be aligned with a specific topic. Maybe they're doing weather research. Okay, so you might have multiple agencies and multiple organizations and multiple universities that are sharing a cloud just for them for specific research, for specific data storage, or what have you. So it's a community that's come together, usually for a specific purpose. that are now sharing the burden of the overall cost of that cloud. Okay, that actually wraps up our conversation and this presentation. So let us jump into our last Kahoot of the night. Launcher up here. Just like before, you can scan a QR code to join, or you go to kahoot.it, put your PIN number in, and join. This is our last game, like I said, of the night. So scan that QR code, put your PIN in, your choice, whichever's easiest for you, and we will get going with our last Kahoot of the night. I know tonight was typically a little longer than normal. I'm glad you guys are hanging out with me. For those of you who are watching this on the record, thank you very much. We're getting, I would say, 3 times the amount of people watching this at their own time, which is cool. I don't care if you're in here in person or watching online, as long as you are learning, that's the important part. Although I do thank you who are here, because now we get to play Kahoot together. All right, let's hop into the game here. Again, you can join if you want. We got the website there and the PIN number. So here we go, 10 questions. What is virtualization? Running a computer system inside another computer. Absolutely. Everybody got that one right. Awesome. All right, next question. Question number 2. What does a hypervisor manage? Oh, thank you all for getting that one right. It is a virtual machine. If somebody got that one wrong, I'd find out who you are, where you live, and tap on your window while you're sleeping and just go, hypervisor, hypervisor, hypervisor. All right, question number 3 for double points. Which hypervisor runs directly on the hardware? Type 1 bare metal. All right, Fearless Orca takes the lead. Next question, question number 4. What is a virtual machine? It is a simulated computer running on a real computer. All right, next question. Question number 5. Still anybody's game. We got some double points here. What does IaaS stand for? Infrastructure as a service. I know it can be a little tricky on that one. All right, next question. Question number 6. Which cloud model gives developers a place to build and deploy apps? It's better to miss the questions on a Kahoot than on the actual certification. So no harm, no foul. All right, PaaS, Platform as a Service. Brave Manatee taking the lead. Next question, question 7. Which cloud model delivers software over the internet? Think of YouTube, Gmail. Right, SaaS. All right, what are our scores look like? Brave Manatee maintaining that lead. Question number 8 for double points. Still anybody's game. Which hypervisor runs on top of an existing operating system? Absolutely. Type 2. That's awesome. The person who missed the other one, you'll never forget it now. That's good. That's good. That's good. I'm glad to see we all got that one right. Next question. Question number 9. Which cloud model combines public and private cloud services? That would be a hybrid cloud. All right. Our next and last question, question number 10, Geek Alert. Which original Star Trek cast member sang The Ballad of Bilbo Baggins? You can go to YouTube afterwards and check it out. It is a funny and painful music video. That'd be Leonard Nimoy, Spock himself. Again, after this, go check it out on YouTube. It will haunt your dreams. All right, let's see what our scores look like. Coming in third place, Fearless Orca. Coming in second place, Yellow Coral, or Coral, I should say, coming in first place. Brave Manatee. All right, y'all. I want to thank everybody for hanging out with us on our last scheduled live stream. Don't forget, we have a whole bunch of other things going on. We've got our newsletter going out. If you can subscribe there by scanning the QR code. We send that out once a month-ish. We also have launched our brand new The AI Teacher Lounge, where we talk about education and AI. We got the newsletter that came out last week, as well as the new podcast. You can find it on YouTube and very soon on SoundCloud. We release those once a week of different topics that I find that I do. So I'll show you workflow, things that I actually do and make a difference. So you'll learn something new every time you do that. But until later, I hope you all have a wonderful rest of your night. Feel free to comment, like, share, all that other stuff. Ask questions for those of you in the Latinos in Tech class. Get that certification. You have our communications on the other thing, all good stuff. So until later, have a wonderful rest of your night. Thank you for joining us and have fun studying out there. Bye-bye.